Let's work on this problem on the board. It says a tiny bulb situated at the bottom of a large trough containing clear water to a depth of 60 centimeters. Okay, this is 60 centimeters and this is the bulb is talking about. Alright, find the area of surface of the water through which the light from the bulb can emerge outside into air. Okay, you need to understand this problem a little before we can start working on this. So I'll draw another diagram here. See, it says like this. If this is a bulb, and I know that definitely this is the denser medium, this is a rarer medium. When light passes in this way, it just goes off like that without deviating because it is a normal. Let's say light falls here, and this guy is the angle of incidence, and definitely the light emerging will bend away from the normal. I can say this is angle of refraction. So let's say anyone who's seeing from here, I can see the bulb to be raised here because of normal shift, right? Now let's say if I increase the angle of incidence, it means this one, I is increasing. Angle of refraction will also increase, right? Or is increasing. Let's say I dash and R dash. If I still increase the angle of incidence, it means I'm seeing it from here. I can see now that as this angle is increasing, sometimes it would become 90 degrees. That is your critical angle. So now what happens? Light would gaze on this and go like that. Okay, see now R became, let's say R double dash here. This is I double dash. Now at this case, I can see that the light is going off like that. It means I can't see this. Here, till here also I can see. In fact, till here also I can see if all light is falling here. Still, I may see it because this is the refracted angle. Alright. Now, but after this point, you cannot see. So come and see this one. Now here, any light which is coming from here can be seen throughout this surface, right? It means you'll see this circle as one bulb basically glowing, and light would come out of this water only from this area. But after this, what happens is light would actually reflect back. I can say, let's say if at all light falls here. Now this would become more than critical angle. This is a critical angle where light is coming 90 degrees from outside. Now this would become more than critical angle, and light would in fact reflect inside the water. It means I cannot see the light beyond this point. Same case on this side. I can see that it's basically a circle, not in fact the two-dimensional picture. It's basically a circle where I can see light coming out as a circle outside. Okay, that's the understanding of the problem. Solving this problem is very easy. What I have to do is only find out R. See how it works. If you can get this R, then you can find the area of the circle from which you can see the light coming out, and beyond this point light actually would enter inside. If at all any light, let me draw a dotted line here. If at all this is light incident, on any point beyond this, light would reflect back inside. It means I can't see this light emerging out. Okay, that's the problem. Alright guys, since we understood the problem, now let's see how to work with this and find the value of R. Once you get value of R, you can find the area very simply using the formula of area, this pi r squared. Now, to find R, let us come back to this triangle here. It says OMB is a triangle. Let me say sine C here. Why sine C? Because I know this guy is a critical angle of water and I have this. So what is sine C? Opposite, that is MB by OB is what I have. And can I get the value of MB? MB is R, which I'm looking for. Fine. Sine C can also be written as R divided by, who is OB? OB is hypotenuse. But I can find a hypotenuse using Pythagoras theorem. Says this squared plus this squared, that is h squared plus r squared. Alright, so I have root of h squared plus r squared. Simply because this guy is 90 degrees here, and these are the two other sides, and this hypotenuse squared, right? So now, from this case, I have one other formula which I can put here. What is sine C? Sine C is 1 by n. And I can write this guy as 1 by n is r by root of h squared plus r squared. Now, in this whole thing, I just need to separate r. Let's see how to work with this. Square on both sides, I'll get 1 by n squared is equal to r squared by h squared plus r squared. The root would go off here. Cross multiply, I get h squared plus r squared is n squared into r squared. I'm looking for r, so keep r on one side. So I can put this r on the other side. It says h squared is n squared r squared minus r squared. Okay, so take r squared common out there. Let me write the other way around. N squared r squared minus r squared is h squared. R squared is out. I'll get n squared minus 1 is h squared. This guy is h. Okay, now what is this? What is r squared? It is nothing but h squared by n squared minus 1. All right, now can I get the value of r? R is nothing but root of h squared by n squared minus r. That's it. If I take h out of this, I'll get what? H divided by root of n squared minus 1. Okay, fine. This is what is r. Once you get the value of r, I can actually solve it using simple formula of pi r squared. Now, in this case, do I know what is h? Yes. H is this height, and he says his height is 60 centimeters. So h is given as 60 centimeters. And do I know n? N is the refractive index of water, which is 4/3 given to you. If you just substitute this, I'll get r as what? I get 60 divided by root of 4/3 minus 1. Okay, that should be 60 divided by root of 16/3 9 minus 1. That will be 60, or I can write this as 16 minus 9, and 16 minus 9 divided by 9, and solve this guy. You will get this answers to be root of 68. Okay, it goes like 60 by, I can write this guy is 7 inside here, and this root of 9 can also be written as 3. 3 goes up, and that becomes 180 by root 7. Solve this guy. I've solved it. You guys use your calculators and find out this value. It is 68 centimeters is what I get. That's the r. Okay, now once I have the value of r, let me find the area of this circle which is required. Area is given as pi r squared, very simple, and pi is, anyway, we know that's a constant value. R is supposed to be 68 squared. All right, so I get 22 by 7 into 68 squared. Use your calculators to solve this. That comes up to around 14529. Is 14529 centimeters squared. Convert this into meters. That's your standard unit. So that should be 1.4, and can write this as 1.453. Okay, that's all. This is a meter square, and I got the area of the circle, and which I was looking for. The second part of the question says, and hence find the critical angle of the water. All right, so to find the critical angle of water, we have a very simple formula. Again, critical angle is given as what? Sine c is 1 by n. So I can just write sine c is 1 over 4/3. All right, then it goes like sine c is 3/4, and solve this guy. You will get sine c as what? C would be nothing but 48 degrees and 34 minutes. We already know this, and there is another way of finding sine c if not using this formula. All right, so that is from this triangle again. All right, he may expect this because this formula is not something which is connected to the diagram. Right, if at all I have to find c from this diagram, I can see that opposite by hypotenuse is what I have. So let me solve it for you. This is also one of the way of solving it. If not that, I can also use the triangle here. Let's say sine c, tan c in this case would be what? Opposite, that is r, divided by adjacent, that is h. So that goes like tan c would be, r is nothing but 68 and h was 60. Solve this guy, you'll get again 68 by 60, and that should be 1.133. If you take tan inverse of this number, 1.133, you will get the same angle as 48 degrees and 34 minutes. So both the ways you can find the same angle. All right, sometimes you can use this also, you can use this also. Why are we working on this? Just because the diagram is given. From the diagram, I can also find tan c, or from the c from this. Okay, it's a very important problem. Try to understand the problem. What you have to do in numericals is more important. How to do is very simple. Just finding out the area with using formulas is very simple. Okay, I hope you understand this.